Assalamualaikum and good day class. Today we will start a new chapter, chapter 3, water and its properties, in which this chapter contains 3 subtopics. The first one is structure of water, the second one is properties of water, and the third one is aqueous solution. But for the week 1, we only cover chemical bonds of water molecules, hydrophilic and hydrophobic substances, and also the cohesive, adhesive, and high specific heat capacity of the water. So for the lesson outcome at the end of this chapter, you should be able to identify what are the chemical bonds that can be found in water molecules, and also to determine the structure and also the properties of water. So water is actually the molecules that support all organisms, all living things, all life. Okay, it is the biological medium on earth in which it exists in liquid, solid, and gaseous state. So you have to remember, water is the only substance or the only molecules that can be found in earth, okay, that have all of these 3 common states: the liquid, solid, and also the gaseous states. And at room temperature, water nearly colorless with a hint of blue, tasteless, and odorless liquid. And most of the all of the living organisms require water more than any other substances, and most cells are surrounded by water, and the cells themselves are about 70 to 95% of water. And the abundance of water is the main reason why the earth is habitable compared to other planet. So the first one, structure of water. So let's look into the chemical bonds of water molecules. So as you can see in the figure here, the water molecule is made up of 2 hydrogen bonds. Okay, we have two hydrogen atoms and 1 oxygen atom. Thus, the molecular formula of water is H2O because it contains 2 hydrogen atoms, 1 oxygen atom. A single hydrogen atom contains of 6 electrons at its outermost, okay, shell, which is referred to the valence shells. Okay, 1, 2, 3, 4, 5, 6, which can actually hold a total of 8 electrons, meaning to say this oxygen atom of the water molecule need another 2 electrons to completing their valence shells. Meanwhile, the hydrogen atom here contain only 1 electron in its valence shells, meaning to say they need another 1 electron to complete its outermost shells. Therefore, when 2 hydrogen atoms are bound with 1 oxygen atom, okay, now the outermost shell, or it's referred to the valence shells of the oxygen, is filled and also completed. Okay, similar with the valence shells of the hydrogen. So, and also the water molecule is a polar molecule. What does it mean by polar molecule? Because inside the water itself, the oxygen is more electronegative than the hydrogens. Okay, the more electronegative, meaning to say they are able to attract the share electron more strongly compared to the hydrogens. Therefore, the water consists of partially positive hydrogen end, which is referred to the hydrogen atom, and also they have a partially negative end, which is referred to the oxygen atom. Thus, it causes the formation of a very strong covalent bonds between the oxygens and also its 2 hydrogen atom inside the water molecule. And these polar covalent bonds in water molecule result also in the hydrogen bonding, okay, in which this polarity allow water molecules to form hydrogen bonds with each other, okay, between one water molecule with another water molecules. So excuse me. So water tend to form hydrogen bonds with other water molecules. So let's look into these two bonds that can be found inside the water molecules. So the first one is a covalent bond. Covalent bond is actually one of the example of the intramolecular forces. Intramolecular forces is referred to the forces that hold atoms or ions together within a molecule, and it considers the strongest chemical bond compared with the hydrogen bond. And the covalent bond is actually referred to the bond between two atoms that form how? By sharing the electrons. So when these two atoms share the electron, they will form what we call as a covalent bond. And there are two types of covalent bond. We have non-polar and polar covalent bond. Non-polar covalent bond in which between the atoms they share equal number of electrons. Meanwhile, polar covalent bond refer to the bonding between two atoms in which these two atoms share not equal number of electrons, such as you can see in this water molecule. And these are the two what we call one differences between non-polar and polar covalent bonds, in which, as I mentioned earlier, non-polar covalent bond, between the atoms they share the electron equally. So since they share the electron equally, meaning to say the atoms have similar electronegativity. Meanwhile, for polar covalent bond, one atom is more electronegative, and and that two atoms do not share the electron equally, okay, due to the different electronegativity. So what does it mean actually by electronegativity? Electronegativity is an atom attractions for the electron in a covalent bond only. So meaning to say, the more electronegative is an atom, the more strongly it will pull the shared electron toward itself. Meanwhile, the hydrogen bond, okay, the hydrogen bond is one of the intermolecular forces that hold the molecules together. And as you can see here, the forces that hold between these two water molecules, okay, not within the water molecules, but refer to the bond between these two water molecules. And it is a very weak weak chemical interaction compared to covalent bond. So what is actually hydrogen bond? It is referred to the bonding between hydrogen atom, okay, to one or highly electronegative atoms such as fluorine, oxygen, and nitrogen. And for this case, it is bonding between the hydrogen atom of one water molecule to oxygen atom, which is small electronegative compared to the hydrogen atom of another water molecules. Second subtopic is about hydrophilic and hydrophobic. Okay, hydrophobic is referred to the substance that scare of water, meanwhile hydrophilic is referred to the substance that love water. So, as I mentioned earlier, hydrophilic molecules are substances that dissolve readily in water. Sometimes we call it as a water loving. Okay, normally they are composed of ions or polar molecules. So, water molecules surround each ions or polar molecules on the surface of a solid substance and carry it into the solution. Okay, and as you can see here, such as the salt and HCl, okay, the positively sodium ion will attract to a negatively charge of the oxygen atom in the water molecule. Meanwhile, the negatively charged of chloride ion, okay, will attract to the positively charged hydrogen atom of the water molecule. Meanwhile, hydrophobic, vice versa, with the hydrophilic, they do not like water, and meaning to say there are substances that insoluble in water or repel water. And normally these molecules are polar molecules such as the lipids, fatty acid, and also vitamin A, D, E, and K. So the water molecules do not attracted to such molecule, and they have so little tendency to surround these hydrophobic substances and carry them into the solution. That's why they are become insoluble in the water and also repel water. For the next topic about properties of water, we only for this time we only cover the cohesive and adhesive behavior of the water, the surface tensions, and also high specific heat capacity of the water. So there are four water properties that facilitate an environment for life. The first one is cohesive and adhesive behavior of the water, the ability of the water to moderate the temperature, and the water also expand as it freezes, and water versatility as a solvent. Now let's look into the first properties of water, in which the water having the cohesive behavior and also adhesive behavior. What does it mean by cohesive and also adhesive? So cohesion is referred to a property in which same molecules sticks together, or what we call as a bonding between the same type of molecules. Okay, for an example, the cohesion between the water molecules, okay, between one water molecules to another water molecule due to the hydrogen bonding. Meanwhile, adhesion is a property in which different molecules stick together. It refers to the bonding between two different types of the molecules, such as you can see over here, the bonding between the water and also the plant cell wall. Okay, two different types of molecules, water and also cell wall. And what are actually the importance of cohesive and adhesive behavior of the water? The first one is it is important for the capillary action, in which it refers to the process where the plant used to pull up the water from the roots to their leaf, which is referred to the water that they absorb from the ground. And also it also important for the transpiration, is which is referred to the loss of water from plants through the evaporation process. You can see clearly in this figure the water that being absorbed by the roots with the help of the root pressure, and then it will pull up. Okay, the water will pull up into the upper parts of the plants due with the help of the cohesion between these two water molecules, and also the addition between the water molecules and also the plant cell walls. Okay, and as you can see here also, the gravity is shown by the water drops beating up at the bottoms of the pine needle trying to fall to the center of the earth. So the property of addition here is that the counteracting of the gravity, as you can see, the addition caused the water to be very sticky to the pine needle, thus preventing it from falling off from the needles. Meanwhile, the cohesion behavior of the water can be seen in the actual shapes of the water drop. Okay, the water molecules here stick together. Okay, and thus forming the shape of this water drop. The second one is that surface tension. Surface tension is referred to an effect within the surface layer of a liquid that causes the layer to behave as an elastic sheet, as just like this figure. So these effects allow small insects such as the water strider to walk on the water, allow also the small metal object to float on the surface of the water, and causes water to form a droplet. And there are lots of importance of the surface tension of the water actually. The first one is for the small insects such as water strider to walk on the water, because their weight does not enough to penetrate the surface, and also the formations of the dewdrops. As you can see, the drops of the water on the leaf in the early morning, the dew, the formations of the dew. Okay, and this is due, the beads formation here is actually due to the surface tension. It gives the spherical shapes to the water drops, and also beading on of water on wax car. So when you waxing the surface of your car, as you can see, when the raindrops fall on your wax car, the water will smoothly slide down to the ground, keeping your car very neat and clean and untouched, because the wax itself is actually referred to the hydrophobic molecules that does not like water. Okay, and they are insoluble in water, so the water tends to undergo addition weakly to the wax, and it bonds very strongly to the water molecule itself. And the third properties of water is referred to the high specific heat capacity. Specific heat of water is defined as the amount of heat that must be absorbed or lost by 1 gram of substance to change its temperature by 1 degree Celsius. Meaning to say, it's referred the high specific heat capacity. The specific heat capacity of the water is referred to the amount of heat that the water must absorb or lost in order for the water to change its temperature by 1 degree Celsius. Okay, so because of the high specific heat capacity of the water will heat up more slowly compared to other solutions or other compounds, and it can hold its temperature longer when heat is no longer applied. So this characteristic is very important because it will enable organism to live inside the water medium that having a very constant internal temperature. And as I mentioned earlier, the importance of high specific heat capacity of the water is to stabilize the ocean temperature, which will later create a favorable environment for the marine life. So I think that's all for our lecture 5. So before we finish our lecture class, please make sure you answer all the questions that I stated here. Answer it in the Google Classroom. For the first question, yeah. So for the first question, the hydrogen atoms in a water molecules are blank charged. A are not charged. Hydrogen atom B negatively charged. C, the hydrogen atoms in water molecules are neutral charged, and D are the positively charged. For question number 2, when water molecules stick to each other because of the hydrogen bond between hydrogen atoms and also oxygen atom, it is called blank. A, addition, B, cohesion, C, high specific heat, and D, high heat of vaporization. And for the last question, describe the term polar as it relates to the water. So please answer all of these questions in the Google Classroom before 10 a.m. I think that's all for today, class. Thank you.